Welcome back to Pale Blue Dot Narratives, where we dive into the latest and most fascinating discoveries in science and technology. As the world around us bursts into bloom with the arrival of spring, so too does the world of innovation, bringing fresh ideas and groundbreaking research. Imagine a future where your cozy sweater isn't just keeping you warm, it's monitoring your health. Scientists are developing thread-based computers that could turn everyday fabrics into smart textiles. And while we marvel at these innovations, we also have to face the sobering reality of our changing planet. Antarctic ice shelves continue to melt, reminding us of the urgency of climate science. But science isn't just about challenges, it's about solutions. In a groundbreaking study, researchers have uncovered new ways to reverse insulin resistance in non-obese individuals, with type 2 diabetes challenging long-held beliefs about the disease. This breakthrough could open doors to more personalized treatments and a deeper understanding of metabolic health. As nature awakens this season, so does human curiosity. With every budding flower and every green shoot, science and technology are growing in incredible ways. The future looks brighter than ever, and we can't wait to explore it with you.
Welcome to Tech Threads, where we explore the fascinating world of technology. Today, we're diving into MIT's revolutionary fiber computers that are set to transform the clothes we wear into intelligent, responsive garments. Imagine a world where your shirt isn't just a piece of fabric, but a fully functional computer. That's exactly what researchers at MIT have created, a programmable fiber that can be woven into textiles, turning ordinary clothing into smart, health-monitoring devices. Let's break down what makes these fiber computers so extraordinary. At its very core, they contain sensors for health and activity monitoring, a microcontroller for data processing, digital memory for storage, Bluetooth for wireless communication, and even a tiny lithium-ion battery for self-powering. These technical challenges overcome by the MIT team are nothing short of remarkable. They've developed something called the Mach-E interposer design, which solves the problem of integrating flat microchips into cylindrical fibers. They've also perfected a thermal drawing process that allows them to seamlessly integrate electronics into stretchable fibers. But what can these fiber computers actually do? Well, in tests, sleeve-embedded fibers were able to identify different types of workouts with 95% accuracy. Machine learning models run directly on the garment, allowing for real-time analysis and feedback. The potential applications are vast. In the military, these fibers are being tested in base layers designed to monitor soldier health in extreme Arctic conditions, where temperatures can plummet to -40°F. In healthcare, the full-body coverage offered by these smart textiles could enable early detection of various conditions through continuous, unobtrusive monitoring of vital signs. What sets these fiber computers apart from traditional wearables? Unlike a smartwatch that's limited to your wrist, these fibers can be woven throughout an entire garment, providing full-body coverage. They can capture a wide range of physiological signals, from heat and sound to light and even biochemicals. And because they're part of the fabric itself, they're practically invisible and far more comfortable than bulky, separate devices. Looking to the future, the MIT team is working on integrating even more sensors and processors, developing AI for more predictive health models, and expanding the technology for everyday civilian use. We might soon see t-shirts that can detect dehydration or jackets that adjust their insulation based on body temperature and weather conditions. The implications of this technology are profound. For the military, it could enhance soldier safety in extreme environments. In healthcare, it could revolutionize how we manage chronic conditions. And in the world of AI and IoT, it could lead to the creation of digital twins of human physiology, opening up entirely new avenues for personalized health and wellness. As we wrap up, it's clear that MIT's fiber computers represent a quantum leap in wearable technology. We're standing on the brink of a new era where our clothes don't just cover us, they understand us, respond to us, and help us live healthier, safer lives. This is truly the fabric of the future. Welcome to our next segment, Planet Pulse, where we explore the vital signs of our planet and the stories that shape its future. Today, we dive into the story of iceberg A23A, the the world's largest iceberg, and its profound implications for our planet. This massive ice formation, spanning 1540 square miles and weighing 1 trillion tons, recently began moving after being grounded for over 3 decades near Antarctica's Filchner ice shelf. As A23A melts, it releases fresh water and nutrients into the Southern Ocean, triggering both positive and negative effects. On one hand, it stimulates phytoplankton blooms, supporting marine food webs and potentially enhancing carbon sequestration. However, it also poses risks to wildlife, potentially blocking access to feeding grounds for millions of penguins and seals near South Georgia Island. But A23A's impact extends far beyond local ecosystems. It's a stark reminder of how melting polar ice is disrupting critical ocean currents, with global consequences. The Antarctic Circumpolar Current, ACC, Earth's most powerful ocean current, faces significant slowdown due to freshwater influx from melting ice. Projections suggest the ACC could decelerate by up to 20% by 2050 under high-emission scenarios. This weakening has far-reaching implications, including reduced carbon absorption by oceans, warmer waters reaching Antarctic ice shelves accelerating melt, and potential shifts in global weather patterns. In the Arctic, similar disruptions are occurring. The Beaufort Gyre has become 20% faster since 2000 due to ice loss, increasing turbulence, and mixing of water layers. There are also concerns about potential weakening of the Atlantic meridional overturning circulation, though this requires further study. These changes in ocean currents have broader global impacts. Sea level rise, where land-based Antarctic ice loss could raise global sea levels by up to 1.7 meters by 2200. Marine biodiversity threats as disrupted currents may allow invasive species to breach natural barriers and alter nutrient distribution, potentially leading to fisheries collapse, and economic and social costs as coastal cities face increased flooding risks, and climate-driven migration could become one of history's largest displacement crises. To address these challenges, humanity must take immediate action by reducing greenhouse gas emissions to limit global warming to 1.5 degrees Celsius, expanding monitoring systems for tracking iceberg movements and ecosystem impacts, establishing marine protected areas to safeguard biodiversity, and fostering international cooperation for coordinated climate action. The decisions we make today will determine whether we can stabilize Earth's climate or face irreversible tipping points. A23A's journey is a stark reminder that no part of our planet exists in isolation. From Antarctic ecosystems to global ocean, currents and rising seas threatening coastal cities, everything is interconnected. The melting polar ice isn't just a warning, it's a call to action. By reducing emissions now and investing in science-driven solutions, we can still chart a course toward a sustainable future. Let's continue learning about our planet and working together to protect it for generations to come. Welcome to Cosmic Conversations, where we explore the mysteries of the universe. Today, we're diving into the fascinating story of Oumuamua, the first confirmed interstellar object to visit our solar system. Imagine this. It's October 19, 2017. Astronomers at the University of Hawaii's Pan-STARRS 1 telescope spot something unusual, a faint, fast-moving object streaking through our solar system. They name it Oumuamua, Hawaiian for a messenger from afar, arriving first. And boy, was it a messenger with a story to tell? Oumuamua wasn't your average space rock. Picture a cigar-shaped object potentially up to a quarter-mile long and, get this, 10 times longer than it is wide. That's a shape we've never seen before in our solar system. It was zooming through space at a mind-boggling 196,000 miles per hour. That's 87.3 kilometers per second for our metric listeners. Now, here's where things get really interesting. As Oumuamua was exiting our solar system, it did something unexpected. It sped up. Normally, objects slow down as they move away from the sun's gravitational pull. But not our interstellar visitor. This acceleration puzzled scientists. Some suggested it might be outgassing, like a comet, but there was no visible tail or coma. Others proposed more exotic explanations, like it being an alien probe. But let's not get ahead of ourselves. So how did scientists study this cosmic oddball? They pulled out all the stops. They used spectroscopy to analyze the light bouncing off Oumuamua, revealing a reddish color similar to objects in the outer solar system. They studied its light curve, how its brightness changed over time to figure out its shape and rotation. They even used thermal modeling to understand why it wasn't behaving like a typical comet, despite its close approach to the sun. Oumuamua's visit was brief, but its impact on astronomy has been huge. It's opened up a whole new field of study: interstellar object research. Scientists now estimate that objects like Oumuamua pass through the inner solar system about once per year. We just haven't been able to spot them until now. Looking ahead, astronomers are gearing up to catch the next interstellar visitor. The Vera C. Rubin Observatory, set to begin operations in 2025, could potentially detect several of these objects. Each year, there are even proposed missions like Project Lyra and ESA's Comet Interceptor that aim to get up close and personal with future interstellar objects. Oumuamua's left us with more questions than answers. Where did it come from? How was it formed? Are there more objects like it out there? As we wrap up, let's reflect on what Oumuamua represents. It's not just a weird space rock. It's a messenger from another star system, carrying clues about the universe beyond our cosmic backyard. Its brief visit has opened our eyes to the possibility that the space between stars isn't empty, but filled with objects that carry information about distant worlds. The next chapter of cosmic exploration has begun, and who knows what the next interstellar visitor will reveal? Stay curious, stay wonderstruck, and keep looking up at the stars. In our final segment for today, Health Beat, your source for the latest breakthroughs in medical research, we're diving into an intriguing study that's making waves in the world of diabetes management. Fish oil. It's not just for heart health anymore. A recent study published in the journal Nutrients has uncovered a potential new role for this popular supplement in managing type 2 diabetes, particularly for non-obese individuals. Let's break down the key findings. Researchers in Brazil conducted experiments on rats that model non-obese type 2 diabetes. They found that administering fish oil 3 times a week for 8 weeks led to some impressive results. We're talking reduced insulin resistance, improved blood sugar levels, and even better lipid profiles. But here's where it gets really interesting. The fish oil seemed to work by changing the body's inflammatory response. It shifted the profile of certain immune cells from a pro-inflammatory state to an anti-inflammatory one. This is similar to what we see in obese individuals with insulin resistance who take omega-3 supplements. Now, why is this such a big deal? Well, about 10 to 20% of people with type 2 diabetes aren't overweight. These folks often have fewer treatment options, so finding something that could help them is pretty exciting. But before you rush out to stock up on fish oil, let's pump the brakes for a moment. This study was done on rats, not humans. We need more research, particularly clinical trials in people, to confirm these findings and figure out the right dosage. It's also crucial to remember that if you have type 2 diabetes and are thinking about taking fish oil, you should absolutely talk to your doctor first. Fish oil can have side effects and might interact with other medications. Looking ahead, there's a lot more to explore. Researchers will be working on human trials, trying to nail down the ideal dose and investigating how fish oil might work, alongside other diabetes treatments. So, what's the bottom line? While this new research is promising, especially for non-obese individuals with type 2 diabetes, we're not quite ready to call fish oil a diabetes wonder drug. It's an exciting area of study that could potentially open up new avenues for diabetes management, particularly for those who have limited options. As always in science, more research is needed. But who knows? Maybe someday fish oil could be swimming its way into diabetes treatment plans. That's all for today's Health Beat.
And that's all for today's episode of Pale Blue Dot Narratives. Thanks for listening, and refer to this episode's show notes for more information and resources about today's topic. For those interested in diving deeper, you can also find more detailed research and insights in our Substack publication at paleblue.narratives. Don't forget to subscribe and join us next time for more insights into the fascinating world of science and technology. Until next time, keep wondering, keep questioning, and keep exploring.